Great. Okay, so I think we have a new person that I haven't seen before on these calls. So let's do a brief intro. So first of all, we have another guest this time, like we had on the previous occasion. So we're gonna have, outside of our usual updates for the Microsoft Cloud services, we're gonna have a presentation around infrastructure as code, Terraform. If you remember on the previous Cloud Talk 16, we had a very good session with Jordan Dimov, who talked about Terraform and Azure and well-architected framework. We're now bringing in another person, a good friend of ours, Fadi Altawil, who's going to speak about his experience with Terraform on a large-scale project. But I'll let him introduce that later on within the hour. So, like I said, our usual agenda, some new updates from the Microsoft Cloud for the last month or so. You know, we're looking into just the stuff that was interesting to us. And the main topic is around ClickOps to infrastructure as code with Terraform. And if there are any questions, we can have a debate, Q&A, whatever we feel like it. Unfortunately, my co-host, who's always with me, is for the first time ever since we started this, is actually not here today. So I'll present on my own. But you know, my name is Nikolai Panchev. I've been working with Microsoft Cloud Services and cloud services overall for the last decade or more, and I've been a sort of an infrastructure security person for most of my career. And I have a wide experience in corporate environments and migrations and all sorts of large-scale projects. Nicky Markov is not here with us, but maybe he will be able to attend the last part of the meeting. He needed to attend the sort of an emergency, but hopefully he'll be able to join by the end of the call. And he has a similar background as me, and we kind of complement each other on many occasions. So that's one of the reasons why we're kind of doing these community gatherings and meetings where we're going to share our experience and impressions of what's happening in the cloud. And also with AI, we have a sort of a separate group in that we do AI updates and demos and all sorts of interesting things around AI in general. So Microsoft updates, just a quick roundup. As far as the Azure topics goes, just a few updates to the well-architected reviews. They will introduce some new properties that came in. They call them change actor. I don't know why they named this, but why they named this way, but just another way you can look into a recollection of events through Azure Resource Graph and some updates to the application gateway for containers. Like I said, these are not all of the updates, obviously, that have happened around Azure, but just some things that we noticed that are meaningful to us that we wanted to mention. On the M365 front, some interesting topics around Copilot and SharePoint in general that I'll briefly get into. The Power Platform, kind of the same. Again, we're very AI focused nowadays, and Microsoft's updates around M365, the Power Platform, and Productivity Suite, the Productivity Suite in general, as most of the topics are around Copilot integration. So it's natural that the news will be around that as well. And as you know, we have a specific vertical about security. So just a couple of brief mentions about XDR. Defender for Cloud and Sentinel. We're very big on security. Overall, we really like working in projects around security. So this is why we kind of include these overall. So well-architected review updates. We had a number of sessions in the past about the cloud adoption framework, the well-architected framework. So we're big fans of this. So any new updates that come around, we want to mention this, and there's some updates to the Azure well-architected framework for Azure OpenAI, specifically that perspective. Azure OpenAI is a very big topic nowadays. It's one of the most requested services. We've built up a lot of experience on that, and also Microsoft working with their clients. So they are reflected that in the architecture framework. They provided some good guidelines lately. So and anybody who's working or getting into AI deployments and Azure can definitely find this useful. The same goes for the machine learning piece in Azure. How to properly deploy environments, machine learning environments. I think about cost effectiveness, because currently when you use AI, this is a big topic. Make sure that the deployment of AI kind of doesn't defeat the purpose of. At the end of the day, we want to be efficient when we're implementing these type of technologies. There are some updates to Azure Front Door, and also just I think yesterday there was an update to the Log Analytics part of the services. So anybody who's working as an architect or you're doing some sort of implementation, or you're trying to align your current implementation, I suggest you go in and review the well-architected framework and its updates. They tend to get updated almost on a monthly basis, so really useful. Like I said in the initial slide, there's some updates to the Azure Resource Graph and how you can pinpoint specific actor, quote unquote, activity over certain resources. I haven't dived into this specifically, what kind of the useful part. I was looking into specific use cases where this was not actually logged in other services. For other services, maybe this would actually be something that can be useful. I know storage account activities, something that people are looking into more. So maybe something you can review and see if you can implement in your daily workflow, but just something to mention. And since AKS is a widely adopted service, Fadi will speak on that in a kind of a broader sense later in the call. We wanted to mention that application gateway for containers is now in GA. I think we had this on the slides probably last year. It was going into preview, but now it's in GA, and it's sort of an evolution of the application gateway ingress controller. So Microsoft is putting a lot of effort to streamline its AKS deployments and the way Kubernetes runs in Azure in general. So they're always trying to tweak these services more and more and make them more in line with their competitors like AWS, which has been doing this for a while. So from that perspective, it's an interesting service to look into. For the M365 updates, the reach of the M365 Copilot is getting bigger and bigger now that it's in GA, and Microsoft allows you to kind of use it directly. You can buy a license. You don't have to be part of a pilot group anymore. So You can directly go and buy these services. So what was happening as customers started using it, they uncovered a lot of negligence in terms of their permissioning, especially for SharePoint, large SharePoint document repositories. And for good or bad, Microsoft is introducing this feature, let's call it a feature, where you can limit the number of results you get from SharePoint search, which also affects what Copilot has reached into. And I think they're doing this so they can give larger organizations an opportunity to kickstart data privacy projects internally, so they can fix their permissioning. And Copilot would not be a sort of a whistleblower on their data and permission. So it's kind of weird. I mean, you wouldn't be scoping your service, because at the end of the day, the co-pilots, the in AI in general, being able to reach out to more data, it's really what empowers it. So actually narrowing down the results, it's kind of going in the other direction. But data privacy issues are really fundamental. And they need to be treated with the utmost urgency. So I think that's one of the reasons. I think they're just probably getting pressure from their customers as well, in order for that to be rolled out as a feature. And another small update to the way Copilot deals in Teams. You can now kind of synthesize key information from your chats. Just expanding the reach and the capabilities in Teams. I mean, the Copilot integration in Teams is probably one of the bigger selling points for Copilot in general. I mean, people kind of like this idea, so they can get highlights from meetings where they have not attended, and just in general what an LLM can do for them when working in Teams. So they're just expanding that capability constantly. So just another thing I wanted to mention about Copilot. As far as the Power Platform goes, just the two updates that I found meaningful. One is the addition of Copilot assistance for filling out forms for model-driven apps. When for the people who've been working with the Power Platform, especially for developers, know that the recent integrations with AI have made the service much more usable, I guess, from the perspective of implementing LLMs and how that can help users use the actual application. And then just another step forward, you'll give the ability for AI to give you suggestions when you're filling out the form, instead of you having to put that in the code, and that will be done dynamically. And based on your app usage, data patterns, it will suggest, hopefully, meaningful suggestions in the boxes while you're typing in the form. So I haven't seen this in practice, so I don't know how good it is, but just knowing how well LLMs are good for this sort of stuff, I think this will actually be working great. And another update, this is actually for the Copilot Studio, which is the new name for Power Virtual Agents, which is part of the Power Platform. They have now extended the SharePoint, the integrations that go beyond just kind of the integrations that you can do. Typically, we would use Microsoft Teams as a way to interact with a Power Virtual Agent or a Copilot created with Copilot Studio. You can technically implement your own code to do it in a web page and other means, but now they have provided an SPFX component that can be reused, and you can integrate a chatbot directly into a SharePoint site, which I think it's can be very useful. They've put out the instruction. It can be customized. They've published the code on GitHub. So there's just a few steps of prerequisites to create the app registrations that are needed to have this running. But overall, I like the idea. I mean, people actually like to have this sort of integration directly into SharePoint pages, especially for kind of communication sites, but also for document libraries. And what the bot can do, it can fetch the information from the site, from pages and document libraries, and can use that as the basis of its data repository. So once you involve the AI features in the Copilot Studio, you can basically have the same experience that we kind of got used to do in Microsoft Teams. So I think that's a neat feature, and it's easy to test, at least, just to figure out how it works. So it's a sort of a recent addition to what they were suggesting. And Microsoft also has a library of custom copilots, not only for SharePoint, obviously, but also for other services that they created. And it has been open source, so you can basically just download, compile the code, and run it. So I think it's sort of neat. And in the era of custom agents and copilots, I think it's just another opportunity. We can integrate these existing services like SharePoint Online. As far as the Microsoft security updates, I think we've done plenty of updates about XDR in the past, and Microsoft's strategy to have the XDR moniker and portal to be the kind of the place where you access most of these services. So they are doing a lot more integrations nowadays. Sentinel and Defender for Cloud are the latest additions to that portal. Again, at some point, I think that this will be the go-to portal for managing the Defender overall. As you know from the past, this has been spread between different compliance security portals and M365, the Azure portal for security, which kind of got away. So now they're trying to unify the experience as the Microsoft Defender Suite is very popular, and a lot more companies are actually trying to implement this as a and removing the necessity to have different security vendors for different services. They were trying to explore and use Microsoft services for that. So this is getting a lot of traction as well. So yeah, a lot of updates to XDR. They have a very active team blog. If you go and if you kind of look into the updates, just overall, the product group in Defender has been rolling out features like crazy in the past 6 months. And there's a new Defender experts for XDR, which is sort of it's Teams integrated, but also it allows you to chat directly with experts from Microsoft, sort of a service for hire that they're trying to position. I'm not sure how successful this would be, but it's an interesting idea. So time will tell. Defender for Cloud updates, just inclusion of different new services and recommendations in the Microsoft Security Cloud Security Benchmark, or MCSB. For DevOps, the critical assets protection is just a way to tag your critical applications, so that will be visible in the different portals around Defender. So if you are analyzing a attack chain or something, you will be able to see these applications come up. This way you can list them out, sort them out in the different portals. So it's a neat tagging feature that they introduced. And we also have compliance standards added to the compliance dashboard. That's also something that they've introduced. Last but not least, Microsoft Sentinel updates. We we spoke about Sentinel so many times. We had a separate session about Sentinel in the past, but at this point, it's really moving up in the list of preferred CMs. And now Microsoft is taking the next step. They introduced a CM migration tool. And this is mainly for Splunk. I mean, Splunk is the biggest competitor for this tool overall. So they're introducing a way to, I think technically it can do other tools as well, but Splunk is probably the biggest CM tool in kind of in the enterprise world. And Microsoft is trying to take a lot of that business by positioning Sentinel. And we know from our previous sessions that Sentinel has a very wide integration with the Microsoft tools that no other tool has, pretty much. And being part of the Defender suite allows you to do a lot more than just on the regular CM, looking at storing logs, fetching information that really goes beyond that, and the whole XDR capabilities really play into the Sentinel integration. So they introduced this migration tool where you give a role, I think an account. You need to have a role in Splunk, and you allow Sentinel to log into Splunk, fetch the necessary information, and prepare your current Azure environment to migrate the specific settings information to kind of kickstart your CM migration to Sentinel. And also new capabilities that are in GA, incident tasks, connectors for syslogs, and CAF. So they're trying to standardize a lot of that, a lot of these capabilities. Microsoft is really big nowadays on open standards. So they're trying to do this for all of their tools, not only Sentinel, but most tools now. Log information is being treated with open standards. So Microsoft has really embraced kind of open source in the last decade. So they really made a positive change for that. And these are basically the updates, short and sweet. There many things are happening in the cloud world, but we're trying to have a kind of a more focused approach. We only try and share what we found meaningful and useful from a corporate perspective, and just from and just don't be distracted by the marketing Microsoft has. All right, great. Now I will introduce our host and guest for today, for the presentation for today, Paddy. Paddy, I think it's time for you to share your screen and maybe kind of open it up, just so we let our guests know what we're going to be talking about today.
Okay, thank you.
I think we can see your screen now.
Yeah, okay. So hello everyone, and thank you, Nikolai, for having me and inviting me. So today's topic will be how to move from ClickOps to infrastructure as a code, mainly using Terraform. We will go through some topics like what actually is ClickOps, what is infrastructure as a code and how we define that, We will go through the benefits of infrastructure as a code over ClickOps. We will then review Terraform as a tool. Then we will have some general migration challenges. Then some of the tools that would be um, great to use, also with some suggestions from my side, what I use. And what I found is great during setup of Terraform and other tools. Then we'll go through best practices, and finally we will go through maybe a case study or something like that, a project that I've been working on, and of course what I learned from it and how to prevent that any issues I had in the future for you, maybe, hopefully. But before that, let's go through who am I? So my name is Fadi. I'm a friend of Nikolai and the other Nikolai, which unfortunately is not present with us. Um, I am currently a DevOps engineer with a broad experience in the cloud, um, various projects from migrations, and of course administration. But yeah, I'm currently focusing on DevOps and some other stuff. Yeah. So that's shortly about me. So going through the next slide is what actually is ClickOps. So ClickOps is the process of clicking through an interface to configure computing infrastructure. Uh, it's a traditional approach and is being used for years, maybe even decades. This method involves configuration and management of any resource that you could think of, either local one or in the cloud. So mainly you go through a graphic user interface or a web interface to configure and create your resources that you need. So ClickOps is characterized by a reliance on manual interactions. So this is making it time consuming. But administrators and users and people who do that, they rely on an expertise to navigate through the tabs, the blades, fill out forms manually, and executing any change that is required by clicking. So this method is popular in the IT infrastructure management, while provisioning servers, setting up network configurations, even managing storages and deploying even applications. But its main popularity becomes because it's easy to use. So you have the ability to manage the infrastructure. Um, most interfaces are straightforward, intuitive, and they do not require any coding skills. So the other thing is that you have an immediate feedback. So once you try to create something, you see if it's successful, if it fails, and you see the result instantly, which some kind is satisfying because you know you've done it correctly. And then you have the accessibility, which obviously everyone without the expertise might be able to perform the tasks because the interfaces are pretty easy and similar. Of course, you would need to have some, but in general, it's going to be pretty accessible. So Despite the popularity of ClickOps, there are significant limitations, and this is why this has prompted to a shift toward more automated and code-driven approaches like infrastructure as a code. So some of the limitations are so I'll go through some of them. Maybe I won't cover all of them, but yeah. So mainly there is a lack of reproducibility. So this means that it's very difficult to replicate configuration. So each operation is susceptible to variations, leading to inconsistencies on how your infrastructure is configured and deployed. And this complicates effort to scale or replicate environments. And we're especially talking about cloud native landscapes where consistency is crucial. Then you have scalability limitations. So while your organization is growing, um, so is the infrastructure behind it. ClickOps, with its manual nature, becomes a bottleneck in scaling efficiently. The time and effort required to manage your infrastructure will increase linearly with a number of components, making it unsustainable for rapidly growing systems. Then you have the human error, which unfortunately will always be part of ClickOps. So any wrong click, any oversight can lead to misconfiguration, downtime, maybe even security vulnerabilities. And I'm not going to go into the financial aspects of a potential downtime. And yeah, this can impact the business operations and reliability. And last but not least, at least for me, is operational inefficiencies. So ClickOps requires a lot of intervention from administrators, which translates to a lot of time, a lot of resources on a lot of repeatable tasks and routine tasks. And this can really divert the attention from more value-adding activities and strategies, which are essentially leading to operational inefficiencies. So while ClickOps has been really familiar and really preferred way to infrastructure management, the limitations, especially the reproducibility and scalability, and to some extent the human error, this highlights the need of an automated method. So shifting towards infrastructure as a code, essentially with tool like Terraform, in my case, represents a paradigm shift, offering an efficient, consistent, and error-resistant way to manage your infrastructure. So this is in general about ClickOps, what are the limitations, and let's now see what infrastructure as a code would present to us and how it will help us. So infrastructure as a code, I'll try to call it IaC shortly, is an approach to managing and provisioning computer data through machine-readable definition files rather than physical configuration or interactive configuration tools. So this method emphasizes the use of software development practices like version control, continuous integration for managing infrastructure. By treating the infrastructure as if it's a software, EIC enables the teams and mainly DevOps to quickly set up and update infrastructure in a consistent manner, in a repeatable manner too. So EIC has become a significant part of DevOps practices because it facilitates rapid deployment, scaling, and management of infrastructure, which is supporting faster software development cycles and more reliable software releases, right? So this is the main goal for us to support the development teams. So in general, there are two approaches for AIC, which is declarative, also known as functional, and imperative approach, which is the procedural. The difference between the two is that the imperative approach is essentially how to do. Declarative is what to do, and imperative is how to do it. So the declarative approach focuses on what the eventual target configuration should be, and the imperative is on how the infrastructure to be changed to meet your needs. So the declarative approach defines the desired state, and the system executes what needs to happen to achieve that state. And the imperative defines specific commands that need to be executed in a specific order to the end with the desired conclusion. So in our case, Terraform is declarative, and most of the tools are declarative. I'll just mention some of them later, I think. Yeah. So infrastructure as a code uses a code to automate the setup and the management of infrastructure. So this means that manually setting up servers, instead of manually setting up servers, storage accounts, storage, entirely network, what you do is you write a script or use a declarative definition to specify that and those resources. So Terraform, tools like Terraform, ARM and Bicep templates, AWS Cloud Foundation and Ansible can read those scripts and or definitions, and they will automatically create for you the resources exactly how you specified them. So this automation process reduces the potential for human error, speeds up the deployment process, and ensures that your infrastructure is exactly in the state you expect it to be. So you write what you need and you get what you wrote. So that's essentially what it is. So automation through AIC not only streamlines the provisioning and management of infrastructure, but also allows for the infrastructure to be versioned, shared, and reused across environments and projects. So I will mention some of the advantages, and then we'll go through some of them. So some of the advantages are, of course, automation of infrastructure provisioning, consistency and reliability across environments, which is very important for large-scale companies, speed and efficiency in operations. You have improved collaboration and version control, easier scalability and resource management, cost savings through efficient resource utilization, which I did write a note for myself that this takes time, and later on you will see why. Enhanced security and compliance. Of course, this is something you would need to focus on in order to achieve it. Then you have a quick recovery from failures and easy rollback, um, reduce configuration errors and operational overhead. And of course, there is the flexibility in integration with existing pipelines, which we'll go through later on. So talking about uh, benefits, um, it's a cycle, but of course, um, we should always focus on the benefits and try to, um, yeah, take them right. So, sorry. So I'll go through some of them again by giving more details what I mean. Well, probably not only me. So automation of infrastructure provisioning. IaC automates the process of creating and managing infrastructure. This is replacing manual step with either scripts or templates. The automation streamlines the deployment of resources, significantly reducing the time and effort involved. And this also enables rapid provisioning and, of course, deprovisioning of resources, making the infrastructure management more dynamic and responsive to development needs. So consistency and reliability in the environment where IaC ensures that every deployment happens in the same way, um, eliminating variations between environments. Of course, you might need variations, but this is something that you could also um, code, let's say, or script or make dependencies in your templates. The consistency reduces the risk uh, of errors and environment drifts, where differences between environments can lead to unexpected issues. So what I mean differences between environments is most large-scale companies do have uh, at least three environments. One is development and testing environment. One is user acceptance, which is the UAT environment. And of course, we have the production. And you would want all of those three environments to be, at least three, sorry, environments to be identical. Uh, so this means that when you're testing in development or staging UAT, they will all behave the same as your production, which will enhance the reliability of the deployment. Then we go the speed and efficiency on operations. So by automating routine and even complex provisioning tasks, infrastructure as code significantly speeds up the entire process of infrastructure deployment and management. This efficiency, of course, in the future, will allow IT teams to focus on more strategic tasks rather than getting bogged down by manual setup and configuration. Faster deployments will also mean that the business can respond more quickly to market changes and, of course, customer demands. You have great and improved collaboration and version control. With IaC, infrastructure configurations are codified and can be stored in a version control system alongside with your application code. Of course, it's a best practice to not do that. Um, so this practice of collaboration and version control not only facilitates better collaboration among the team members by making it easier to share, review, and even edit infrastructure code, but it also provides a historical record of changes, enhancing accountability and allowing, of course, easy rollback, which is something very important. So easier scalability and resource management will also allow organizations to scale their infrastructure up, down, whatever the needs are, whatever the demands are. Um, any scripts or templates can be designed to automatically provision additional resources when needed and scale down when the demand drops. This dynamic scalability ensures optimal performance and user experience without manual intervention. There we go now with the cost savings. Of course, that goes through efficient resource utilization, automating infrastructure provisioning and deprovisioning helps you to align resource usage with actual needs. This should avoid over provisioning and wasteful spending by ensuring resources are only consumed when needed and scaled down or even turned off when they're not. And by this, organizations can and might achieve significant cost savings. Something also as a benefit is enhanced security and compliance adherence. So IaC enables the integration of security practices right from the start of the infrastructure provisioning process. So templates can be designed to adhere to compliance standards and security best practices, ensuring that every deployment is compliant. You have automatic compliance checks, security scanning also can be incorporated into your pipelines, which can further enhance your security posture. And the idea of that is you can do that prior to deploying your resources. Of course, you can always have Azure Defender to look after you, but the idea is to be proactive and not reactive. Then you have something really important, at least for me, for the business, which is quick recovery from failures and easy rollback. So if there is an event of a failure or the detection of a critical issue, infrastructure as a code would allow you to quickly recover by enabling easy rollback to previous state of the infrastructure. Of course, if the issue is related to infrastructure, but we all know that it's not our fault usually. So since all configurations are coded and versioned, restoring to a known good state is straightforward and can be achieved with minimal downtime, which is something you can assure your business. You have reduced configuration errors and operational overhead, which minimizes human error by automating provisioning process. So this process reduces the likelihood of configuration mistakes that can lead to system outages or security vulnerabilities if your configuration is not correct. Additionally, the operation overhead is significantly lowered as manual tasks are replaced with automated process, allowing teams to manage more resources with less effort, which is what the business would want. for you to do more work, right? With less effort. Then you have a flexibility in integrating with either existing pipelines, or maybe you can create new ones. So it's designed to integrate seamlessly with um, existing pipelines, allowing infrastructure changes to be rolled out as a part of the application deployment process. This flexibility ensures that application and infrastructure updates can be delivered in tandem, which would reduce the delays. It will improve the efficiency and hopefully lower the downtime for you and your company. So these are some, maybe not all of the benefits that I see uh, of infrastructure as a code over ClickOps. Um, and I would like now to go to the next topic, which is specifically Terraform. I'll go a little bit um, about it. So I do believe that Terraform is one of the most popular infrastructure as a code tools, which allows DevOps and not only DevOps teams to automate their infrastructure provisioning uh, while they're using reusable, shareable, and human-readable configuration files. Terraform can automate your infrastructure provisioning in both on-premises and cloud environments, which is something really useful. By using Terraform, teams can describe and provision all the components of the infrastructure in the form of code. The code resides in a configuration file that can be easily shared, reused, and versioned. Those files will help create a consistent workflow to manage your entire cloud or data center infrastructure if you have a local data center and its resources through their lifecycle. So Terraform configuration files are declarative. Um, they describe the infrastructure's end state, which is something that we previously discussed. The tool itself will handle the underlying logic, and it will eliminate the need to write the step-by-step instructions, which is, let's say, more easy. But of course, it's really about your use case. The files codify the application programming interface APIs for cloud platforms and other services, sorry, which makes it easy for the teams to provision resources from any cloud provider, implement security compliance guardrails to standardize the infrastructure, and utilize standardized and reliable workflows for consistent infrastructure provisioning and collaboration, of course. So how does Terraform work? As I mentioned, Terraform uses APIs to automatically create and manage infrastructure resources. All major cloud providers provide accessible APIs that work with Terraform and enable the tool to create declarative configuration files. These providers are listed in the Terraform registry, which is quite huge. It also lists modules, policy libraries, and tasks that teams, your team also can use to quickly deploy common infrastructure configuration and automatically manage them via code. So Terraform allows teams to create sustainable infrastructure as a code. The workflow occurs in mainly 3 stages. So the first stage is you write the code. A user, or I, in my case, defines the required resources in a configuration file. These resources may be across multiple on-premise or cloud environments, multiple providers and services. So once you write the code, you review it, you confirm that everything is in place. Uh, the next stage would be the plan. Here, Terraform creates an execution plan which will describe the actions it will take to create or update your infrastructure. So this will show you each resource that it will create, each resource that it will modify, what um, configuration it will update for you in an existing resource, and anything related to that. So once you have the plan, you need to approve it, which is the uh, third stage. It will check automatically for resource dependencies, and um, it will create all the resources by their dependencies. How that's in general for Terraform, which is nice tool, at least for me. So, of course, there are challenges that you would face switching from ClickOps to infrastructure, and transitioning presents several challenges that your team would need to overcome to ensure a successful and efficient shift. So key obstacles are cost management. So this is what I mentioned previously, is that while um, infrastructure as code is more cost effective than ClickOps, the transition can lead to unexpected expenses due to over provisioning or maintaining idle resources, which would require vigilant planning and monitoring. Um, Also, there would be the duplication of resources, um, and then this will have your costs go up in the sky. Other challenge would be collaboration. So adapting to the new tool, and not only Terraform, but any tool that you might use, and workflow necessities, the development of new collaboration practices to manage infrastructure code across multidisciplinary teams. So while you are used to doing ClickOps and you need to shift to infrastructure as a code, collaboration at the beginning might be very difficult for you and your teammates. So this is something that you would need to work on. There are, of course, security concerns. The move introduces new security dimensions, especially regarding access to code repositories and the management of secrets within the infrastructure as a code configurations. Happily, Terraform has provided several ways for us to do that. For the secrets, I mean, access to code repositories also is something that is very important. So you might restrict access to your infrastructure to IT personnel, but if you allow them access to the code, they can basically do anything. So this is also an important part. While it will increase your security posture, it's something to be considered. And of course, the sooner the better. So it's maybe better to go through the security and the access controls at the beginning before you start shifting and transitioning, so that you don't have to um, react, right, to some issues, security issues that might come. Then you have state management and drift. So you need to ensure that your actual state of infrastructure will align with the code. Um, this also demands vigilance to um, prevent configuration drifts. The idea is that your code and your infrastructure would need to be identical. Um, this is something that also Terraform provides um, as a tool inside of it. So you have also learning curve. This is maybe also part of the collaboration. Um, Teams will face challenges of mastering infrastructure as code syntaxes, tools, and best practices, which may be a steep depending on their background and experience. So maybe um, trainings would be something very good for your team. Um, Best practices for code standards and anything like that would be good. Um, so while integration with existing systems is an advantage, so it's a challenge. So integrating infrastructure as code practices with existing systems and workflows can be really complex, which would require a careful planning to ensure compatibility and minimize disruptions for the business. Uh, Also, other things are tool selection and standardization, choosing the right infrastructure to as a code tool. Uh, of course, there are multiple available, and standardizing these tools across the project can be daunting, but it's critical for managing uh, consistently and efficiently. Uh, so we also have compliance and governance. Adhering to compliance requirements and implementing governance policies with infrastructure as a code practice adds a layer of complexity, especially in some of the highly regulated industries, which one of the cases is my cases. Uh, then you have the challenge of cultural shift, moving from ClickOps to infrastructure as code. It's not just a technological change, but is also a cultural shift toward automating, and it's requiring an adaptability from the entire organization, not only the team that will work. Uh, Infrastructure as a code can introduce dependencies between modules and external resources, which would require a careful management to avoid conflicts and ensure smooth deployments. So addressing all of these challenges would involve great and strategic planning, continuous learning and development, of the teams, and the adoption of the best practices in collaboration, security, and tooling. So by recognizing and proactively managing these obstacles, your team can fulfill and leverage all the benefits of the infrastructure as a code. So it's not only I am implementing infrastructure as a code and I instantly have the benefits. It's not, unfortunately, like that. So transitioning infrastructure management practices for uh, greater efficiency and agility. Um, of course, there are other challenges which I might not have encountered or um, I have not mentioned, but these are challenges that I've also faced, and I do believe they are to be addressed. So once you start addressing those, um, and at the beginning of the process, where you select your tools and resources, I would personally go with one of the, let's say, most, how do you say it, popular, right? Yeah, sorry. So one of the most popular too is Visual Studio Code, which is integral part of uh, a DevOps day-to-day work. So this is maybe one of the best open source IDEs by Microsoft. It's available for all platforms. Um, so it has great features, um, and probably that's why it's so popular. It has extensibility, so it supports a wide range of programming languages, even out of the box, including uh, JavaScript, TypeScript. You have Terraform. You have also Terragrund, which I will mention in a bit. Um, PowerShell, of course, Bash, and any other language that you might think of. So it's not limited only to those. So the functionality can be further extended with thousands of extensions, which are available through the marketplace, which are also covering additional languages, additional tools, and services. Um, I will show you in a bit a few extensions that I believe are vital for Terraform, and not only Terraform, and Git, of course, which comes to the second tool, which is Git. This is probably the one of the best version control system, which is designed to handle anything from small to huge projects with speed and efficiency. So it has a distributed version control. Unlike the centralized version control systems, every Git directory on every computer is fully fledged repository with complete history and full version tracking capabilities, which is independent of network access or central server. So any version and any change you have is tracked locally on your computer, which is really great. It has data integrity. Git ensures the integrity of its data with a content addressable file system. So every file and commit is checksummed, and the repository can be cloned to restore the entire history. You also have branching and merging. So branching and merging capabilities are incredibly efficient, facilitating multiple workflows and making it easy to experiment and collaborate with different teams simultaneously. Then one of my maybe favorite, or maybe because I'm working mainly with TerraGrunt and Terraform, is TerraGrunt. This is a thin wrapper for Terraform, which provides extra tools for working with multiple Terraform modules. So it's designed to fill in some of the gaps in Terraform's functionality, making it easier to manage really complex or large-scale Terraform configurations. TerraGrunt is created to address common challenges and repetitive tasks that arise when using Terraform, because um, you have environments with heavy usage of Terraform across multiple projects or teams. Key features of TerraGrunt are try configurations. It took me a few months to understand what dry is, which is don't repeat yourself. So TerraGrunt allows you to keep your configuration Terraform code dry by defining your backend configuration, your providers, and other repeated settings in one place. So you don't have to have it in multiple places. And then reusing them across your multiple Terraform modules. So this reduces the duplication and simplifies management. Um, as Terraform, TerraGrunt has remote state management, which simplifies uh, remote state configuration. It can automatically manage remote state, log files in a variety of backend solutions, ensuring that the state is kept consistent and secure across teams. Yeah. Uh, there is an automatic dependency management, which provides a mechanism for defining dependencies between your Terraform modules. So once you have Terraform dependency between resources, but then you have dependencies between your modules, which is very important. So this is particularly useful for managing the order in which modules should be applied in your infrastructure. So um, maybe moving to the next tool, which is TFLint. This is a static code analysis tool. It's designed for Terraform specifically, and it's widely used to implement infrastructure as a code. TFLint focuses on detecting potential errors, misconfigurations, even style violations, and opportunities for improvement in your Terraform code. So it complements the Terraform's built-in validation feature by catching issues that are not covered by Terraform. So Terraform itself does have a built-in validation, which is helping developers to adhere to best practices and avoid common pitfalls in their infrastructure configuration. So maybe some of the features that good to mention are error detection. So it can identify syntax errors, incorrect module references, and other issues that could lead to runtime errors. Best practices enforcement. It can enforce a set of best practices for writing Terraform, which will help teams maintain consistent and readable code base, which is very important. You can also provide specific rules, which, for example, working with Azure, it can flag configurations that are not compatible with the provider and best practices or potential API constraints. You also have custom rules that you can implement. I won't go through how exactly TF-Lint works. We'll go to the next tool, which is Azure DevOps, which are actually DevOps and GitHub. So maybe all of us know and use either DevOps or Azure DevOps or GitHub, but just in short, Azure DevOps is a suite of development tools um, which is designed to support the complete software development cycle. It enables your team to plan your work, collaborate on code development, build and deploy applications, and ensure project tracking and management. So it has it has support for a wide range of programming languages. It has also a lot of tools incorporated, frameworks, and other uh, tools. So key features are, and maybe the broadly used ones by DevOps teams are Azure boards, Azure repositories, of course, Azure pipelines, and some might use test plans, which are useful. GitHub is, going through the next one. So GitHub is a platform for version control and collaboration. So yeah, so it lets developers and DevOps engineers to work together on projects from anywhere, which actually it's making it one of the most popular code hosting platforms. The difference between DevOps and GitHub is that Azure DevOps offers a more comprehensive suite of tools covering the entire software development lifecycle, where GitHub focuses more on social coding aspects. So if you have the chance to go through Terraform's repository, you will see that all of the codes from there are exactly shared in GitHub. That's why I mention it. Uh, so these are some of the main tools that I personally use on a daily basis. And going through that, I would like to show some of the extensions that I use, which help on my day-to-day work. So this is the Terraform extension, which is really, really helpful. So it adds a syntax support for the Terraform and Terragrund configuration. So some of the features that it represents is syntax highlighting, basic validation, and of course, Terragrund configuration support. You can see it has autocomplete, it has auto suggestion. It will give you all of the required options for each resource. So as you can see, in that case, you're creating a random password. It will give you all available options, like what should the length be? In that case, upper, lower, number, special, if you want to use it or not, and any other available option which you might need. Of course, that's a really simple one, but it's very useful. Of course, another place to look for those is Terraform's documentation, which are really, I would say, great. Then you have one really important extension is gitignore generator. So gitignore essentially is something that you would not want Git to track for you. This usually is sensitive information, sensitive folders, or even folders that you do not want to be version controlled in your current repository. So the main purpose of the extension is to generate the file for you. It can update your existing one if you already have. It has a set of predefined configurations which you can choose, and it will automatically add those. Or you can also manually modify the files. I found that very useful because it can add extensions that you might have forgotten to include in the git ignorer file. So very useful tool, essentially for me. So the next extension that I would suggest to everyone is the YAML extension. It provides great features. YAML is really important in infrastructure as a code entirely. And this extension provides validation. It detects whether the file is valid or not. It has document outlining. It has auto completion. So it also have hover support. When you hover over any of the nodes, it shows description. It also helps you with formatting. So these are the extensions that I would personally suggest everyone to have added to their VS Code. Since I went through that, I would go through some of the best practices, which we would need to go through. I might not have time to go through all of them, but I will try to at least go through the ones that I really think are very important. And those are, as you see, are assess and plan, start small and expand gradually, and modulize your Terraform configuration. So I would go with the assess and plan first. So it is really important to understand your current state. You would really need to do an audit, um, do a comprehensive audit of the existing infrastructure. This will include documenting all hardware, software, all configurations, and services that are currently in use. This will help you understand your starting point, which is crucial for identifying dependencies and potential challenges. Then you have to define your objectives, clearly articulate what you aim to achieve with the shift to infrastructure as a code. This could range from reducing deployment time, improving system reliability, achieving cost effectiveness, maybe foster better collaboration across development and operations team. And you would also need to have a success metric, establish a KPI to measure the success of your transition. Once you have those two, you would need to create a strategic plan. So not all of your, not every component in your infrastructure will be equally suitable for immediate transition. So you would need to make a prioritization based on factors like complexity, criticality to the business, and potential benefits you would would previously add as a success metric. So it's really important to start with low risk and high reward small projects to gain momentum and build on your confidence. At least this is what I did. So this is the second best practice for me, which is start small and expand gradually. So adopting that approach is a cornerstone best practice when implementing IaC or integrating any actually significant technology into your organization. This method allows teams to manage risks, learn effectively, and most importantly, demonstrate value to the stakeholders incrementally, which is crucial, at least for me. So a bit more expanded look into why you would need to start small is identify a pilot project. So you need to select a small enough project to manage easily, but significant enough to demonstrate the benefits of the infrastructure as a code. So ideally, it should be a project with manageable scope, clear objectives, and where the outcome can serve as a proof of concept. So this basically leads to low risk, what I mentioned before, and high reward. So this should minimize the operational risk to the business. So you wouldn't want to interrupt from the beginning their business. So you would look for opportunities where automation can bring really quick wins, such as reducing manual labor. So then you go to defining a clear and achievable goal. You need to set specific, measurable, and I see that I found that is a so it's called SMART, which is specific, measurable, achievable, relevant, and time-bound goal, SMART goal, for your pilot project. And success, no matter how small, can help you build momentum and support for wider adoption, right? So you also need to have a very good feedback mechanism. So yeah, other very important, at least from my perspective, practice is document and share success. So any process, any challenge, any solution that you encounter or implement, you would need to document. This will help you and your team understand how to move forward, and it will serve as a valuable resource for scaling your efforts. Maybe other thing is to engage your stakeholders to demonstrate the value of IaC, highlighting, of course, your wins, which are time saved, errors reduced, and improvements in deployment frequency and reliability. Then you have the gradual expansion. So once you have the small success and based on the pilot projects, you will start to gradually expand the use of IaC to other projects. So you would need to choose subsequent projects that build on the knowledge gained and introduce new complexity gradually. So don't go to the hardest one directly and the most complex one. This is a recipe for failure. It's really important to have a standardization. Use standards for best practices, templates, modules that can be reused across projects. This will speed your adoption. So in general, the start small and expand gradually would allow the organization to manage the complexity of adopting infrastructure as code in a controlled and measured way. This approach will not only mitigate risk, but also builds a solid foundation of knowledge. And I maybe would go through this one too, which is really important, at least for me, which is modularize um, your Terraform configuration. So by doing that, so this actually involves breaking down your infrastructure code into reusable and manageable pieces. These modules encapsulate a specific set of resources and configurations that can be reused across different projects. So I will show you later on an example, but just on the top of my head, you can modulate storage accounts and everything related to their configuration, and just reuse that module instead of having 10 resources for every storage account, because it has a lot of configuration associated with the storage account. You just call the module, um, and give the required variables, and it will create everything for you because you already created a module for that. So you need to understand the benefit of modularization, which is reusability that allows you to define, uh, as I said, a common set of resources and configurations. You have manageability by the organization. You can manage complex configurations more easily. And then you have collaboration and sharing. It facilitates collaboration among team members. So then you have to identify which resources would be good to be modularized. So this, of course, will not go without the first best practice, which is assess and plan. You would need, once you assess your environment, you would need to look for common patterns. So anything that you see that is repeatable across your environment is something that you can modulize. And then design the modules for reusability and flexibility. So maybe one more thing, although I also mentioned it previously, is version control. Version control is really a fundamental best practice for managing infrastructure as a code, and not only. That also includes Terraform. So the benefits of the version control are change tracking, collaboration, rollbacks and history of changes, branching and experimentations. I I wouldn't go too deep into that. That's another topic. Version control is really, really important for your transition to infrastructure as a code. I see that we're going ahead with the time, so I will show you a bit of my experience. So my case study, in that case, the company profile that my project is assigned to is in the gambling industry. This is a huge industry. It has really strict compliance requirements. So because of that, the size of the company's footprint in Asia, not footstep, is around 50 subscriptions, which is quite a lot. So because of country rules, there are regional deployments. So each country they operate in, even state that they operate in the United States, they have different set of rules, um, different compliances that they need to follow. So their regional deployment consists of dev test environment, UAT environment, and production environment. And then they have global resources that are used by all regions, by all regional deployments, again, divided into dev test, UAT, and prod. So um, my use case is global. Regional is already in Terraform, and the global piece would need to be transitioned to infrastructure as a code with Terragrund and Terraform. So the global subscription, contains a lot of resources. I would just mention that the monthly cost of that subscription goes beyond $1 million, which is quite a lot. So part of the services that we had to work with are API management services, application services, function apps, logics apps, um, Azure Cache for Redis, availability sets, Cosmos DBs, virtual machines, of course, log analytic workspaces. So as you see, there is a huge variety of resources. So we started with an assessment of that environment. We had to document every resource, every configuration that it might have for each of the resource, find the pattern, and one of the, I would say, really benefits for us was that we were allowed to modify on dev test, of course, initially, resources that do not comply with certain standards. So as I said, the global environment was entirely ClickOps. So I would say that maybe 1/3 of the resources inside were not used, which imagine having to spend 1/3 of 1 million on resources that aren't used. That's a huge amount to pay for something that you do not use. So we started assessing the environment. We identified the used and not used resources. It was really difficult because this did require collaboration with a lot of teams, with a lot of people, confirming for each resource at least 3 times. So as you can imagine, this is really very important because you might end up increasing the cost, and you would end up with a lot of unusable resources, regardless if you have codified them or not. So once we had all that information, and we had a clear path on how we would move forward, we started creating modules for all the resources that are repetitive. Of course, depending on the use case, the modules are either in a separate repository or in the local repository. So that's a brief overview of some of our modules. Of course, not all of them were created by us, so but most of them were. And we did have to modify them to comply with our needs. Of course, changing them also represents a challenge because you would want to update them to help you, but you do not want to change how the teams are using them at the moment. So the difference between having a repository-based module and local-based modules is that you would use a repository-based modules if you are calling. So first, it's good that your module would need to be really huge, and you wouldn't want to bother your main code with that module. And you are also only using it a couple of times, so you wouldn't go beyond 5, 6 times to call it, because every calling will trigger a download, which on your side will increase the deployment time. But on the other hand, those would be a key modules. So let's take, for instance, AKS cluster. So AKS cluster would be a key module, a key resource in your environment. And you would want that to be fully tested. You would want that resource to be checked, double checked, even maybe triple checked before you implement it in production. While if it's locally for you, it might go unnoticed, which might cause a problem. So in the other case, you would use repetitive modulation, where you require, let's say, in my case, Azure APIM is creating resources within APIM for each workspace that I have. So this means that I would call that module maybe 60, 70 times, and I don't want to download that externally. So that's why it's inside. Changes over that module, even unnoticed, might not cause a big issue like any of the other, let's say, DNS. So imagine changing the DNS. So you might break the entire environment, or changing an AKA cluster configuration, which will trigger a rebuild. Of course, there are safe mechanisms to prevent that from happening, but while you do that, you learn from your mistakes. And one of the mistakes, of course, is destroying an existing cluster and rebuilding it, which will cause only downtime. And that's really not that good. But that's why you have development environment. And yeah. So this is a simple module. I'm not sure how good you can see. So one of the modules that I worked on, and it's maybe easier to show, is the Key Vault one. So imagine having a Key Vault that you need to create maybe 10 times, 20 times. Why would you want to go and create that? To code it for each place you want to create it. Why would you do that? You will go and create a module for that. And this module will include, sorry, just a second. Yeah, so this module will include creating the actual key vault. So you will think, yeah, but that's only one resource. But unfortunately, no, it's not, because you create the resource. Then you have an access policy that you would need to create. So you create a key vault and you want to assign um, permissions to that key vault. Then you have a storage account which you want to create to store diagnostic settings, which is also a separate resource. And then you would have a management policy for your storage account, which is something that you would modulize too. So it is okay to have a module within a module, and it would really simplify um, your entire work. So you know that creating a storage account requires, let's say, 10 more resources to be created in that. So you have storage account, you have access policy, you have management policy, you have retention policy, and um, what else? I can't even tell all of them, to be honest. So, and instead of having to do that for every key vault that you would create, you just modelize it. So the easy and the good part is that um, you can, so uh, once you modelize your resource that you need, you can specify the variables that you would require, and you will have the freedom to use whatever you need. And what you only need to do, what you only need to do is pass any information that you would want to your module, as you see here on the left. So you have the module, you have a name, what the name would be. Of course, the source. In my case, that's a repository. And then you have all the variables that I would need in order to create that key vault. A retention policy, workspace, log analytics workspace ID, region, environment, tenant, resource group name, even location. Then I have a list of access controls. So this is also something that you have access control and then you have access policy. So you have the access control is from where you can access your key vault, and access policies. Yeah, you can access the key vault, but do you have access to, let's say, secrets or anything else in there? And if you do have, that's the access policy. You can set those permissions. So you are um, having a set of um, objects that you pass, right? And then in my case, I have a dependency. So in order for me to create that key vault, I would need to have the resource group created, which resource group is in another module. As you can see in the previous slide, that's the shared infrastructure. It's this one, functional app Azure infrastructure. Inside, I create a lot of resources. I wouldn't go through them at the moment. So yeah. Uh, then we would go. Um, uh, so this is essentially what I was talking about. Here you can see how much resources you can modify. So yeah, you have a key vault, but then you have um, networking, you have uh, properties, you have access configuration, and thankfully there are stuff like, let's say, Defender that are managed on um, a subscription-based scale, although you can do it on a resource group, but every company, I would suggest going through even management group level This will assure that all policies are enforced on all subscriptions. So one of the main challenges is once you have um, identified the resources to import, so you have written the code, you know what is the resource, but now you need to make the connection between the two, because if you go and do the 3 steps, which is code, plan, and apply, you would end up maybe duplicating your resource, so you have it twice. So this is not the ideal way. So what you would do is you would go and import what you have. So in my case, I am importing access policies. This is allowing me to so this is allowing my pipeline to have access to the access policy. Sorry, to the key vault secrets. That's the access policy. So as you can see on the left-hand side, I have a lot of workspaces. That's part of the Terraform configuration. We have utilized the use of PowerShell, which would automate mostly our work. It is really a best practice to even automate that, because you wouldn't know in the future what you might need. So once you import, so you create the resource, sorry, you have the resource created already. You have the code. The next step is to import. So once you import, it is really important to confirm that what you have imported complies with your code. So what this means that, let's say you have a key vault setup, because I already showed you that. The key vault, has access policy, retention policy, purge protection. So you need to have all of that configured in your code. If you apply and you don't have configured any of those, you may either remove them or add them. And this might not be something that you would want and you would need. So what you would do, you would plan your change. You will compare the changes that will be made to your current resource, and then you would need to modify your code to be essentially the same as your resource. So the idea is that you wouldn't want any changes because you already have the environment and the dependency. Yeah, so this is also a bit of what our clusters do have as a configuration. This is a dev test environment in my case. So as you can see, we have the default node pool, Windows and Linux node pools, pretty small, to be honest. But as I said, that's dev test. Also, a lot of namespaces. Each of those namespaces contain resources. In general, we have around 200 replica sets, which results in around 350 pods. And I think there is a secret for each replica set, but I haven't counted, or maybe even more than one secret. But yeah, that's in general. So that's while you try to import a configuration like that, you would really have to be really careful. And this is how the configuration will look like modularized. Unfortunately, I am not able to show you the actual module because doesn't fit into, I think even in 5 screenshots, it will not fit because it does have a lot of options and a lot of settings. But in general, so we have again the source, which is where we would call the source from, the repository. Then do we want to deploy a system pool? Do we want to have a service sider? What is the environment that we're going to use? So in my case is dev test UAT in prod. Then depending on a lot of variables, I have a system pool size. So if it's prod, if it's an active cluster and stuff like that, then same goes for Linux pool size. Then you have Azure location. You see there are a lot of variables that I pass to that module, something that I previously showed for only the key vault, of course, but it was easier to fit in that. So as you can, but of course this is not part of the start small and expand gradually. This isn't small. I would say that this is maybe part of the expanded at the end probably. I would go with I did go actually with key vaults and storage accounts at the beginning, which showed great result. Our project manager did really like it. I'm not sure if it reduced the time for deployment, but it did simplify the code because you have only one resource. Essentially, it's a module, of course, but what the developers see, because they also have access to that, they see one resource and not 200 lines of code. That's in general. For that, I'm gonna move a bit forward, which is lessons learned. So in my case, we did not do a great assessment. Maybe it was because we did not have a strong relationship with the other teams. So therefore, our assessment wasn't good, and so was the plan. So if you don't have a good assessment, you can't create a good plan. So modularizing is really important and really reduces the time to focus on other stuff, because it will only take you a couple of hours to create a module, of course, for the simple ones. And then you can focus on the big modules like the Kubernetes one that I showed you. You would really want to avoid complexity. If you know that there is a simple solution, try to somehow use it for your use case. Of course, that's not always possible, but I did try to add complexity to look, how to say it, smarter in front of the colleagues. It didn't work. You know, it doesn't make you look less a professional if you use something simple. To be honest, it's quite the opposite, because it's just a simple thing. You don't need to complicate it. Maybe something important at the beginning, we did have access to merge our changes, which was triggering builds, which on the other hand was triggering deployment and destruction of some resources. That's why we did implement on our PRs additional approvers. So PR is pull request, which will essentially merge your changes to the main branch, which is used by everyone. Something I learned, unfortunately, the hard way is keep an eye on your costs. They really expand quickly, and sometimes it might be really problematic. So set limits, set alarms. That includes workspace. Maybe that's one really important is workspace. Log analytic workspace is something that drains your money, right? If you enable logs and all of your resources are heavily used, log analytics workspace can skyrocket. And that's actually the thing I learned the hard way. So uh, other things are collaboration. I was previously uh, the Lone Ranger, do it myself, but in time it turns out that collaborating is, um, first it might save you a lot of time. There will always be someone that has done something that you need to do now. So it's not a shame. It's not a unprofessional to ask someone for help. Um, it was difficult for me personally to go through that. So, but I really found a lot of positives in it. So I hope that I'll be more collaborative in the future. And uh, last but um, not least is communication with stakeholders. So you need to constantly update them, showing your positive progress, sharing your obstacles. If you have any blockers, they are the most of the time they are the people that would help you. So it's really important for you and for them uh, to show your progress. Uh, and I would also add one, although I said last, but something maybe a trivial. You need to learn from your mistakes. Um, I always laughed at that because, yeah, it's something that you think it's, yeah, I made a mistake. I know that I'll learn from it. But yeah, you just need to, and that's why actually documenting and going through documents is really useful because once you document even your mistakes and once you go through them, you'll see, hey, I already did that. So I wouldn't go through it again. I don't want to go through it again. So yeah, that's maybe a little bit shorter case study from what I wanted, but it did show some key points there, I believe, and I think it's part for the Q&A. And if anyone has any questions.
Thank you, Fadi. By the way, Nikki is back. He joined the
Yeah, I
call.
saw him. Hi.
Hello, guys. Sorry for missing half of the meeting. But yeah, I'll be able to listen to the second part, which I think it was really important and motivated, especially with the lessons learned, the actual things that we learn for such a big client. Because as we all know, the scale is important. So yeah, my question would be, if I may,
Mhm.
how you can apply what you learn to, let's say, smaller clients, which does not have the maturity for, let's say, working with infrastructure as a code tools.
So what I believe is that smaller companies tend to use ClickOps because they know it's easier, right? And it's a instant success, as I mentioned. You missed it, but you go, you click, you create it, and it's there. Um, Unfortunately, they do not realize, and this is something that you need to show them that regardless of if they know or not, they are doing repetitive tasks. So you need to show them. So assessing their environment and even having, let's say, 10 virtual machines, let's say, you would go and tell them, you did that by clicking, right? So you spend at least 30 minutes per VM. So that's around 5-6 hours, right? You would code that for maybe 2 hours, let's say, maybe even 5, but then you would be able to build 100 machines for them. So if the company would like to grow, they would want new infrastructure, and this is how you will show them by encouraging them to grow their business, and showing them that while they grow efficiently, you will be able to easily match their growth under the hood, let's say.
Right. Yeah, that's I see. And do you think that the AI can help here? Let's say with let's say learning curve and being able to help them to step in faster?
Definitely. I started using AI even for my day-to-day work, and I would really say that even for simple tasks, it saves you. So let's face it, you cannot remember everything, right? You cannot know everything. Instead of doing extensive research for something simple, you can have maybe not 100% accurate answer, but you will have the basics and you would know how to start, which would essentially save you at least, I would say, 30% of your time, right? So, and this is what I do, to be honest. So, and I do believe that everyone should do it.
Absolutely.
AI should become an integral part of your day-to-day work. So
super very happy to hear that, and also I think everybody would be very happy to learn more about how we can use AI in order to be more efficient using and effective managing deploying our infrastructure with infrastructure as a code. So I guess this could be something that you can include in some of the next sessions, huh?
Maybe.
Super. Okay. Thank you. Any other questions? I see you're done is asking questions, so maybe we can
Anonymized repo solution.
Hey, Fadi, I'm able to unmute.
Super.
Great demo. I was wondering if what you have presented as a solution is publicly available, of course anonymized if this was used for customer purposes, like a small MVP of the pipelines and some module examples.
No, I don't have that publicly available.
It will be great if some of it can be shared.
Yeah, I do believe it's possible. It does not have, as far as I know, of course, it does not have any corporate information. So yeah, I would look into the possibility and share that.
Super.
Great. Well, I think we can call it a day. Thank you so much, Fadi, for attending the call. We'll definitely bring you on in the future Cloud Talk sessions. And yeah, we'll catch you next time, everyone.
Thank you.
Absolutely. It was
bye, guys.
great
Thank
to
you,
have you.
Bye.
Cheers. That was